or point of inflection. So we have 41 on page 291. So we have S of x equals negative 0.131 x to the third plus 0.661 x squared minus 2.021 x plus 6.865. Find the points of inflection and discuss what they mean. Okay, so we are jumping over the first derivative in the sense that we need it, but we're not going to analyze it because we are only asked to determine points of inflection. So let's find S prime because we can't find the second derivative without finding the first derivative. So I need to multiply this by 3, negative 0.0393 x squared, plus I need to multiply this by 2, 2 to 1.3 x, and minus 2.021. But now I have to find the second derivative to multiply this by 2. So I think I have, what is it, 68700 x plus 1.322x. Perfect. So we found the second derivative. How do I find the inflection points? What? Potential inflection points if they exist. So again, x is in months, and y or S of x in units, millions. Yes.
I have a question.
Yes.
In the S double prime, isn't it supposed to be 1.322? Just without the X?
Yes, of course, of course. I said 1.322, but I wrote x. Yes, 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 of course. Thank you. Sorry about that. Thank you, thank you. My apologies. Good. So now what do we do with the second derivative in order to find potential points of inflection?
Find where it's equal to 0 or undefined.
Yes. Since it's a polynomial function. So then I have negative 0.0786 x equals negative 1.322. So I have 1.322 over 0.0786. So I'm going to share my screen. Sorry, it's kind of crooked here. Sorry. So in y equals, I don't need y equals. I meant to 1.322 divided by 0.0786 and enter. So this is x, and x is in months. 16.82. Okay. And you know what we do next. So here's x. So x is, I don't know, 0 to infinity, but 16.82. The second derivative only is 0. We need to study its sign. So here's the second derivative. So plug in 0 and tell me the sign, and plug in 100 and give us the sign. When we plug in 0, what do we get?
Positive.
Good. And when we plug in 100, we're going to get negative. I need to make sure that it changes sign, because 16.82 comma S of 16.82 will not be an inflection point if the second derivative does not change sign. But it does. So it opens upward, the function opens upward between these two, and it opens downward between these two. That's why 16.82 comma S of 16.82 will be an inflection point for sure. So in order to find this, I have to plug it in the function and find this number. but it's definitely, this is the inflection point. So notice one thing, a quick question here, and I'll stop. So when we set the second derivative equal to 0, this 16.82 is what we obtained, x equals 16.82. But this is basically where s prime of x is either max or min. Because when we analyze the second derivative, we are basically thinking of the first derivative. So when the second derivative is 0, then the first derivative has to have a max or min. So that's what the question is asking us here. Let me just come back to this for a second. It says, interpret its meaning in terms of the rate of change. The rate of change refers to s prime. Okay? So all it means is, at an inflection point, the first derivative, which is the rate of change, is either max or min. Okay? So at this point, at this inflection point, the first derivative is either max or min. The rate of change, because basically we analyze this based on this function.